Okay. And now let me share my screen. Chat. And let's minimize this. All right, where to go? Okay, how's everybody doing? Glad it's Friday?
Definitely.
Okay. All right, so we are in our last stretch here. Let's see, we are, oh wow, my computer all of a sudden started overheating. What's going on? What are you doing that is so hard? Okay, whatever. Okay, yeah, so let's see. So we are right there. On week 12, we're finishing up week 12. And so starting today and all next week, I'd like to give everybody a chance to propose certain things that we might want to discuss about the project. And also we'll go over the P1 assignment that is about, it's the first project related assignment, which is designing and creating the database. We'll go over that. We'll see again how that is related to the requirements of the project. It is due a week from now, in which then you will be responsible to do the second assignment, project-related assignment, which is designing an ORM data model or connecting to it somehow and creating some kind of front end. And then after that, it's all, focusing on finishing up the project, which is due Monday, April 26th. Okay. So yeah, we'll do a little bit more of Mongo, since we did talk about how to connect to it from JavaScript. We can do a little more of that and show you how that could be used for, as part of completing your project. That's definitely one alternative. Again, most of the semester we've been focusing on relational databases, but certainly we could use non-relational databases to accomplish similar things. So yeah, right. So before we get started, any questions about the schedule, about any upcoming deadlines, about the project? Who's on? We got 30 folks. Not at all. Okay.
Professor, I have a question.
Sure, go ahead.
You've probably answered this already, but is the project something that we can accomplish alone?
Yes, absolutely. There's a limit of up to 4 students that can be in a team, but absolutely you can work on your own.
Okay, thank you.
But, yeah, you do need to join a team anyway, even if you're all by yourself. That's only for grading purposes. Okay. All right. If there are no questions, I'm going to go over the project assignment that is currently due next Friday. if we go to today's module, it should be available here. Yeah, P1 database design and implementation. So in this first assignment, I see that a lot of you have already started this, right, and already have some deliverables, which is great. But you know, it's all due. This part of the project is due next Friday. Let's go over it and see how it's related to the overall requirements, and then we can either you know, try to I can show you how to get started, what it is that we are expecting from you, or we can start looking at perhaps specific questions that you might have for your project, right? And if it's worth discussing it in class for everyone else, then yeah, we can certainly use today to discuss that. If it's something more specific about a particular environment or something that is not it's broken for you or some bug or whatever, then I would rather discuss that privately with either you or your team, and we can certainly address it there. But if there's something that's useful for everyone, then definitely I'd love to discuss it here in the lecture. So yeah, so let me bring up the requirements for the project and how that pertains to this assignment, P1 assignment. Okay. All right. So the P1 assignment is it's due next Friday, and it says the following. It says there are two deliverables for this assignment. First is a data model. Design a normalized database that meets the requirements discussed in class, which is this one, okay, this requirement. And describe the database as a UML class diagram containing class names, properties, data types, relationships, and cardinality. Reify the classes and relationships with the intent of implementing the database as a relational database. Although it says the intent is to implement it as a relational database, feel free to use non-relational databases if you prefer, right? So if you use Mongo, if you prefer to use Mongo, that's fine. If you prefer to use other non-relational databases, right, that you might be familiar with, that's absolutely fine as well. Your database should model at least one type of user, two domain objects, relationships between users and domain objects, and relationships between domain objects, right? So that's just a small excerpt from the overall requirements, which we're going to go over. And then the second deliverable. So this is a PDF we're looking for, right? A UML class diagram that has that it's basically a class diagram that contains at least one user, multiple domain objects, and relationship between them. So that's one of the deliverables. The second deliverable is converting that UML class diagram into an actual database, right? Again, most of what we've covered for the last 2 or 3 months has been how to convert UML class diagrams into a relational model. But you know, if you prefer, and if you feel comfortable and confident enough, right, you can instead implement it as a non-relational database using Mongo, right? So you have that freedom. If you want to do it safe, right, I would stick to non-relational databases, right, just MySQL. But if you want to feel adventurous and you feel you have the skills, then I absolutely would encourage you exploring using MongoDB or other non-relational databases. Absolutely. So yeah, so first design it and then actually implement it. Now, by implementation, right, we only mean that you're gonna do all the create statements for all your tables. You're gonna do some inserting some data just to try out the tables work and that they're related correctly. So that's the database part. Okay, so you're not actually going to build an application around that for this assignment. So this assignment is only the UML diagram and the relational model or non-relational model implemented as classes or collections. Whether you go relational world, it'll be tables and rows, right? If you go the non-relational world, right, it'll be some collections and documents in there. Okay, so that's this first assignment, P1. The next assignment, P2, which is not out yet, will be out next Friday, right? We'll ask you, okay, now you have the database, right? Well, now populate it, put some real data in there, right? Maybe, you know, if these are, if it's a online store, then you know, find some products that your store is selling and actually insert data that represents your store. Okay, if it has customers, then you know, fill up your table with actual customers, and then you know, build a simple user interface and a small piece of code that actually connects to that database, right, and uses it, you know, retrieving data and displaying it somehow. Okay, that's the second assignment. That's next week, right? For this week is just design and implement the database. Did that make sense? All right. So if that makes sense, let's let me show you, you know, what that would look like, right? For, you know, designing something for this for these requirements. Okay, so I'm gonna do the P1 for you, right? Following the final project requirements. Let's see. So it says it's its largest 4-person team. It's just me here. Data model requirements are UML diagram, described to database as UML class diagram, blah, blah, blah. And that has class names, properties, data types, relationships, cardinality, reify it, blah, blah, blah. Okay. User model, right? So the requirement is that you have at least one user, okay? Meaning one description of some human being that is representative of somebody who might use your application. Okay, and that depends on what it is you're building, depending on the domain, right? If it's movies, well, then you could be an actor, right? You could be a fan, right? You could be the director. You know, whatever types of users exist in the domain of movies. Okay, if it's if it's an online store, then you might be a customer. You could be a seller, right? You could be a store owner. You could be a product provider or something, or you could be a reviewer that reviews products. Right? So it depends what it is, right? If it's an educational website, then you could be faculty, you could be a student, right? You could be in the staff, you could be the dean, you could be all sorts of folks that are representative of the domain that you've chosen. So let's do that. Let's choose a domain and build something around that. So a tool that I like to use for data modeling that I've seen a lot of you be using is Lucid Chart. Lucid Chart is a great tool for building UML diagrams, all sorts of diagrams. So let's see, documents. If I go 3200, let's create here a folder, and let's see, we have maybe Lucid Chart document or folder, and we'll call this 2021. Under 2021, let's create a document, and let's create a UML diagram for a topic of choice. Okay, so the topic of choice that I'm going to choose, I want to build, let's say, we want to build Canvas. Say we want to use Canvas. It's an online learning management system. And what are the types of users that Canvas is designed for, right? So, well, Canvas is designed for people like me, like faculty. Is designed for people like you or students. And so those would be reasonable human beings that I would capture here. Okay. Let's see, shapes, it's flowchart. I want UML, so let's grab UML here. UML, there it is. And so let's create a class diagram. And so let's say this is a faculty, and other types of human users might be students. So students. And now a lot of the properties that faculty and student will have, they're probably going to be very similar to each other, or actually the same. So for instance, both of them are going to have things such as, first name, right? We'll have a last name. And so instead of repeating this, and we don't really care about the operations. So instead of repeating this, oops, let me copy this. Instead of repeating that, we use specialization or generalization, right? And basically we put a superclass, right, that captures the things that are common to all of them, right? First name and last name are common to all users, so we'll call this user. And then we use inheritance. We say that faculty, instead of having to redefine all those things, right, it's just going to inherit. Both student and faculty are going to inherit from both of them. So we don't really have to repeat this. Right, so we could put it at a higher level, and we use the correct endpoint here. So yeah, so now we have both faculty and student inheriting from user. What else? So now we can say that faculty and students are just a special case of users, right? So they might declare their own special properties, right, that only pertain to faculty or only pertain to student. So faculty might have maybe whether they're tenured, right, and that'd be Boolean. Whether they have an office. So this might be a string. Okay. And the student might declare things that only pertain to students, right? So maybe the student has a GPA, right? Maybe this is a float. Okay, whether they have a scholarship, whether they're I say they are yeah, scholarship. Okay. All right, so these would be two reasonable human beings that would be representative of the domain of online education or an online website, learning website like Canvas. Okay, so that covers this requirement, right? And probably you might want to add these two as well, right? That are part of this here. Plus and plus here. Oh, did I use the wrong plus? Oops, I copied with the wrong font. Liberation Sans. Liberation Sans. Oops. Whatever. Liberation Sans and there we go. Okay. All right. Excellent. So let's keep going. Okay. The other requirement from the project is that, right, we need at least two domain objects. Okay. In the faculty and in the Canvas world, right? If we look at the application, we can start looking at what do we have here. Well, look at all these things. Look at that, right? There's a whole bunch of things that are non-human things that we need to keep track of, right? You know, if I just go to my dashboard, you know, what are these things? These are what? These are courses, no? These are courses, and it looks like these are not two courses. They are the same course, but two sections of the same course, right? So right there, courses and sections are some valid domain objects, right? Non-human things that we need to store in the database, right? So we can start filling that up. Right? We can say, okay, well, a couple of them might be courses. So course, right? And you might have different sections for the same course. So section. Okay. What else? What else do I have? Well, you know, if you go into a course, if you go into a particular course, right? A course seems to have all sorts of things, right? Looks like one course seems to have a whole bunch of modules, right? So that might be also worth storing, right? Where you have a course seems to have multiple modules. Okay. And these are it, right? Modules, resources. And so module seems to have names, and then each module seems to have a whole bunch of things in here, right? You can, it says add. You say add here. Looks like you can add all sorts of things to a module, right? An item looks like they call them items. You can add many module items, right? And the items could be assignments, quizzes, files, pages, discussion, right? All these are all valid domain objects that are not human being things that we need to keep track of. Like an assignment could be a domain object. A quiz could be a domain object, right? Well, let's stick to something simple, right? So, so this would be a module item, perhaps that's what they called it, right? So it looks like a course looks like it can have many sections, right? So we can capture that. We can capture that and say that you know, you have the multiplicity. So you can say that one course can have many sections, right? So we can capture that. I don't know if you can see that, but it's kind of small. Is there a zoom here? View, zoom in. There we go. There we go. There we go. So we have one-to-many between course and section. Both of them seem to have somewhat like a title that you can describe. The title of the course looks like they both seem to be strings. Section also seems to have a title. Okay. And a course seems to have a lot of modules, right? So we can say also this is one, you know, one course seems to have any number of modules, yeah, 0, 0, 0 or more. Okay, probably will want to remove this on the right hand side like that. Okay. So this is starting to take shape. A module can have many module items, right? So let's do that as well. Multiplicity. So one module can have any number of module items. So module item. Okay. Module seems to, these all seem to have like a title. Okay. Okay, so now what about module items? So module items, if you go back here, looks like, you know, if you're going to add a module item, looks like you can add assignments, you can add quizzes, you can add a page, a discussion. Okay, so there are a couple of ways that can be modeled. You could say one way to model that is that module item could be of different types, right? And so there's two fundamental different ways that that can be implemented. Could be implemented normalized and denormalized. So normalized could be implemented as follows. You could have an assignment. This is an assignment. An assignment is a type of module item, right? So you could model it as follows. You can say assignment, assignment here is a type of module, right? So you could do it using inheritance. That's one way, right? Then you can have another one is a quiz, right? Right, where you can also do inheritance here. Okay, this is one way. The other way, so this is considered to be normalized, meaning each one of these, right, has its own class. It's going to have its own table. Okay. Right. The other way, alternative way, would be to do it denormalized, right? And to denormalize it, another way that can be done is that you have a type here. You have a type, and this could be module type. Okay, so that's another alternative way. You wouldn't do it both ways. You would do it either having a type, or you would have the subclasses. Now, if you have a type, then you would need to have an enumeration, right? So let's add an enumeration. Interface. Where do you have? Is it this one? No, this would be a. Wait, there must be an enumeration here. Uml sequence, development, blah, blah, blah. Uml case, Uml diagram. There's no, really? Interface, class. Well, I don't see enumeration, but anyway, we can override this of enumeration. And this would be the module type. And then here you would list the different types, right? You would have assignment. You would have a quiz. What else do we have? What else would we have? Let's see. We have a add. So assignment, quiz, file, page, discussion, external URL. Right, so let's do that. External URL, page. What else? Quiz file. Okay, you get the idea. You get the different types like that. Okay, so where this module type, right, is this. Now, the way it's implemented in a relational database is that these would be its own table with the, with 4 or 5 records with the valid values would be in that record. And those would be the primary keys of that table. And then the module item would have a foreign key that points to that module type. So the only possible values for that foreign key could only be the primary keys of the module type table. Okay, so yeah, and in here the module type item would have all the fields that you would have in the assignment. Let's look at that, right? If you go with the normalized implementation, you would do something as follows. Right? You would look at all the properties of assignments. So if you go to assignments, you say, I want a new assignment. So what are the properties of an assignment? Well, it's got a name, right? So let's do that. An assignment has a name. Okay. Right, assignment has a name. It has a, looks like a description. Okay, it has points, how many points? So this looks like that's an integer. Maybe not this. Yeah, do not count. Okay, submission type. So submission type, that sounds like an enumerated data type. Right, that looks very apt for an enumerated data type. Okay, submission type. So this would be submission type. Right, so that maybe that would be a good example of an enumerated data type. Let's do that. So this might be submission type. Submission type. And looks like the submission types are text entry, website URL. So text entry, website URL, media recording, so media recording, file, upload, and that's it. And it looks like you can, it's a checkbox. See that? It's checkbox, many of them. So you could have lots of them. So this would be not one submission type. You could have lots of them. So this could be an array like that. Okay. There could be more than one type of submission type, and that's how you would capture it in UML. Right now, to implement that in a relational database, there are no arrays in SQL. Okay, so the way it would need to be implemented would be that you would need a separate table where you list all the valid submission types for this assignment. Okay, so we need to reify this, right? We need to reify that. We haven't reified it yet. We'll come back to reification in a minute. Okay. What else would we have here? Assignment, allowed attempts, right? Unlimited, limited, right? So maybe this could be Boolean, maybe it could be called unlimited attempts, and it's Boolean. So if it's true, then yes, you can submit it many times. If it's false, you can only submit it once. Okay. All right, then you have maybe when is it due, right? Due date. So this date. We have available from, and available until. Okay, there we go. So we have that assignment. Now for quizzes, so we say let's cancel. Let's look at the quizzes. Quizzes might have what? So we say new quiz. Quiz, again, quiz might have a name. This might be name. It's a little bigger. You have instructions. You can have a quiz type. So quiz type. And that looks like an enumeration. All right, there it is. It's 4 types of quizzes. All right, so let's create another quiz type as an enumeration. So this is quiz type. So quiz, oops. So quiz type. And the different types would be whether it's practice. So practice. It could be graded. Could be graded survey. So maybe survey. And ungraded. Okay, so those are the types of quizzes. So here, the type would be quiz type. Okay. I don't know what else. Shuffle answers. How's that? So that would be Boolean, maybe, right? Shuffle answers. This would be Boolean. Time limit. So time limited. So what is Boolean? and then the time limit minutes. So time limit minutes. So that would be an integer. I don't know what else. Due date. And available from date and available until. Okay, so that would be something like that. Now, so that's if you decide to go the normalized way, right? You would have separate tables. One table for assignment, one table for quizzes. If you go the denormalized way, right? I'm going to put here in parentheses, denormalized. If it's denormalized, then the denormalized implementation. Actually, maybe I'll put it in a separate class. I'll leave that here. Let me cut that here. So this is in parentheses normalized. Okay. Now denormalized. Let me copy that. Denormalized. Let me put it down here. Denormalized, sometimes it's easier to implement, right? So it would be the same relationship. It would be the same relationship. Go from here to here. And you remove that. So denormalized, the way you would do it is that you would just copy all the features from all of them, from all the subclasses, right? Oops. Okay, so you have all the features from assignment, and then you would also copy all the ones from quizzes, copy, and you would remove the duplicates, right? So for instance, this is named twice, so I'm not going to have it twice. Description is there already. Points, submission type, unlimited attempts, due date, because these three are duplicates, right? But now I would have additional here a type. This would be module type, and this is this would be module type, right? And the module type is declared over here as a enumerated data type. Okay, right? You could go both ways. Okay, you can go both ways. All right. Okay, so I think we have plenty. So by the end of your design session, you should have a class diagram that you can share with the TAs and myself. Right. So that's the first half of the first P1 project related assignment. Right. That makes sense of what we're asking for. Makes sense, right? It's basically just applying what you've been practicing all semester, but applied to an actual something that you can build. Okay. All right. Before we go on, any questions? Again, I want to give you a chance if you want to have a discussion on something specific about your project. If you have a question that you think might be useful to discuss it here in class.
Hi, Professor. I have a quick question.
Yes, please.
So I was wondering if our domain objects, if it's a little more niche and it's not obvious how they should relate to each other, is there a way we can provide context for those for the first assignment?
Oh, of course, please. Yes. That's where that's where UML can shine to document for people that don't know about your domain. Right. If I would be modeling something of which I don't know the domain, I would absolutely do it wrong. Right. I would not know, for instance, if I didn't know about education, I would not know perhaps that that courses can have many sections, and perhaps I only think about courses, but I never think that, oh, wait a minute, students don't enroll into a course, they enroll actually into a section, right? So I might absolutely miss the fact that I need this extra one-to-many, right? Because I might not be familiar with that domain. So absolutely, UML is definitely useful for explaining to someone else who doesn't know the domain on how are things broken up, because we don't know the jargon, we don't know the terminology, we don't know the relationship between certain things.
Okay, so the UML diagram we're providing is assumed to be correct for the domain knowledge, and we're mostly looking for how that's being implemented in the following database implementation.
Yeah, and I could certainly make some I can make some comments if you come up with a UML diagram that I know very well about that domain, and say, wait a minute, you're missing something here or there. But if you come to me with a UML diagram about astronomy or chemical engineering or physics or mechanics or whatever, quantum physics, I'm not gonna be able to comment on it or criticize it in any way, right? So I'll take it at face value, whether it's well implemented or not.
Okay, thank you so much.
Also, I should say that knowing about a domain can be good and bad, right? Definitely coming into a project, having built, being an expert, say, in a particular domain, and I absolutely want to bring in folks that have a lot of experience in a particular domain. That could be mostly good, but it also could be hindering, because once you are an expert in a particular domain, it makes it harder to consider many other things, other different ways that it could be done, right? And or looking at things in a different way. So you could bring a lot of baggage with you, and assumptions, right? And default implementations. It's like the problem of somebody who has done something for so long and becoming such a niche expert at something. So that could be useful, right? Definitely, most of the times it's useful, but certainly it could be negative as well, and about being able to think outside the box. It says, well, can we reinvent space travel? And things that used to be obvious now seem that are since things that we thought were unintuitive actually turn out to be the correct answer. So yeah, it could go both ways. All right, great question. Anybody else? All right, so it says, how many records should we make for the sample data? Well, I would say that it depends what you're implementing. If if it's an application where folks are entering their own data and you own your own stuff, right? Maybe I'm creating my own CD library or music library, and I have my own CDs, and I enter them. I might have several dozen CDs, and each one has an average 10 songs. Then presumably I can have hundreds of songs in there, and so that would be representative for one user, right? And if you're going to make this realistic, presumably a real application might have hundreds, thousands of users. And so I'm not going to ask you to realistically be representative of some real application out there, but you should have significant data in there that that if I log in, or I'm using a particular user that you're going to be creating, you should have several dozens of records for each user that I can make it interesting for me to navigate and take a look at samples of data, right? Now, for the final project, we're going to ask you to fill out a form where you're going to specify exactly how you want us to grade you. And so we're going to ask you, okay, what, tell me the steps that will demonstrate that you have successfully implemented this feature, right? That you have the user data model. And so your steps might be, start up the application, click here, click there. Notice that we have a whole bunch of users. Click and select a particular users. Click and select Alice. Go into Alice. Notice that Alice has first name, a last name, a username, password. Try it a couple of the other users, and yes, we have successfully satisfied that requirement. And then we'll ask you, okay, well, tell us how we're going to verify that you've satisfied these two domain object requirements. So again, you're going to say, select courses, right? And then I'll see a whole bunch of courses, and then it says, well, now go into a course, and then I can see a particular course. And then one of the requirements is that one domain object needs to be related to another domain object, right? And then it goes like, well, while you are in the course screen, you'll notice that there is a sections link. If you click on sections, you'll see the sections for that course, right? So we're going to ask you to fill out and tell us exactly what steps to take to verify that you have indeed succeeded in fulfilling each one of these requirements, right? So that form, it'll be going out soon, and you're going to fill it out, and you're going to tell us, do this, do this, do that, and the TAs and myself are going to follow your instructions exactly to the letter, using your user interface, whatever user interface you end up using, and verifying that you have indeed succeeded in fulfilling these requirements. We're not going to try and break your application. We're not going to try and crash your application. We might randomly go here and there just to see that it works. Okay, we're not going to actively try and crash your application. Yeah. So right. So we'll ask you how you want us to test it. Make sense? All right. Any other question related to the project? All right, no question. Okay, so I'm going to continue. I'm going to continue working on this first assignment, and the assignment is asking us to create. The assignment is asking us to create. Let me see. Assignment. A database implementation. Okay, so again, sorry, this could be implemented either using a relational database or a non-relational database. And since we've spent some time lately, discussing non-relational databases, why don't we continue that discussion here, so that we can practice a little bit more. Okay. So having come up with this design, we see that we need faculty, we need students, we need this users. Okay, so let's implement that. I believe we had created a database already that describes users, and I think we had already talked about faculty and students, and we also had discussed in our coverage of MongoDB on how to implement inheritance, right? And we said that the way we would implement it is using the denormalized implementation, right? And I think we showed you how to do that, right? We created a couple faculty, we created a couple students, all in one table called users, right? And we had a type here. We had a type of user. So we already did this. So type. And this is user type. And the type of user could be an enumerated data type. So this could be user type. And it's going to be either faculty, student, staff. Okay, so let's see if we have that already. Let's see. Here's, I believe this is the homework, the MongoDB assignments. We had created a data here. Let's see what's in there. It looks like we had a couple of collections for, I'm guessing, for users and sections, I believe we even created. So let's start MongoD and Mongo to start playing with this. Let's see. Okay. Let me start PowerShell. And let's go into that directory. And we were, let's say, into documents and NEU and 20 DB design, section 03. We have the Mongo assignment. Okay. And so let's start the Mongo database here. So it says Mongo D, DB path, and then this is data. All right, that's up and running. So in a separate PowerShell, let's minimize that. Oops, let's see, PowerShell. And let's go back into that directory. Documents, NEU, DB design, section 03, and we're going to start Mongo. And let me make this a little bigger. So show DBs. So, oh, that's a good name for an alternative to Canvas. We'll stick to Whiteboard. So Whiteboard used to be an alternative to Blackboard because we didn't like Blackboard. But recently I've found out that I'm not too happy with Canvas either. So let's keep implementing an alternative to our online learning management system. So that yeah, we hate Blackboard, we hate Canvas, and somebody will hate Whiteboard at some point. Yeah, so do use Whiteboard. And let's see what we have here. Collections. Looked like we had users. Let's see what we got. The users. And we had a couple of users here. We had Alice, Ada, Bob, and Charlie. Looks like we have Alice is a student, Ada is a faculty, and we don't know what Bob and Charlie are. Okay. And we had already started with this way of keeping track of inheritance, right? That all records, all documents seem to have properties that are common to all of them, and some properties that are only relevant to either student or faculty, right? Some of them we don't know what they are. We don't have to know what Bob or Charlie are. Okay, presumably let's make them students, right? So we do DB users update, and we would update maybe Charlie. So let's update the person whose username is Charlie Garcia, and we make them a type. Type is student. There we go. And let's do the same with Bob Pope. And this is, we'll do the first name by our last name Pope. And this is last name. There we go. So we got two students. So we have, there we go. We have a faculty, students. Oh no, we didn't do the set, did we? We didn't do the set, so we completely lost those two users. That's fine. We'll create a couple more. And yeah, we lost them. That's fine. All right. So once we have this, we want to create the domain models, and I believe we had already started on that, right? We had created here let's see, where do we do that? We did in the hello. Oh, there we go. Hello JS. This is where we left off on Tuesday, right? We showed you how to connect to Mongo, right? We talked about bringing in the Mongoose library, how to connect to that particular database. Here is our data model. We're saying that we're going to connect to a user's collection, right, which contains Ada and Alice, right? And this one represented the structure of the data that we want to manipulate. And then we talked about the model from the schema that allowed us to interact with that collection, right? And you implement the user model by giving it a unique ID, and then given the schema that you want to be able to CRUD. And then user model provided the functions, right, that allowed us to either insert using create, update or change a particular document, be able to remove and retrieve data from the database. So basically all the CRUD operations that we would want. Okay. All right. So this is all existing in hello.js, kind of like in a ad hoc way. Let's put some structure here. Let's actually implement it how we would do it in a production environment, right? In a real industry environment. So here's what we would do, right? We would follow more or less the same architecture that we had for when we did in the Java side, right? In the Java side, if you remember, let's look at that. Let's open up the Java implementation, because it has a lot of architectural things in there. Okay, so it's Java, and there we go, right? Yeah, so if you remember, there were some things here that we split it up into different things, right? The models were the data structures that we wanted to communicate with the database, right? We have the blogs, the reviews, the users, right? And there's the mapping, what table they're going to be connected to. So these are what? This is very, very similar to what our schemas are, right? I mean, that's what the schema is. The schema establishes where is this going to be saved in the database. Here in relational databases, we call them tables. In non-relational databases, in Mongo, we call it collections, right? And then same thing here in Java, we have all the properties, right? The strings, the data types and whatnot. And we have the same thing in the non-relational world. So this is equivalent to this right here, right? And these, right, is equivalent to that. So basically, this is the data model of what it is that we are storing in the database. So we're doing the same thing here in MongoDB. So we should split it up the same way, right? Following the same kind of architecture. Right? So we'll put a directory called models. Okay, models. And what goes in there? Well, everything that describes the data structure that we are storing in the database. And so here it is. This is what we're storing in the database. Yes. So let's do that. And this is for the users. So let's create a directory for users. And in there, we want to put the schema, right? A schema file that describes users. Right? So we're going to put new file, we'll call it users schema. Again, schema is a fancy word of saying structure, right? How is it that you structure the data? So we're going to copy this whole thing and move it in here. Okay. But we need Mongoose, so let's require Mongoose at the very tippy top. There we go. And finally, we're going to export this so that others can use it. So module exports equal user schema. Okay, this is only so that others can import it. You know, in Java, you see all these imports. See that? Right. So in JavaScript, the equivalent is that we do require. See this require? This require is the equivalent of importing, right? Of bringing in stuff. And you can only import stuff that is public. See that? Only when somebody exports, the other one can import, right? So same thing here. We are exporting. We're saying that this is publicly available to everybody who wants to import it. And we do it this way, right? All right. So other than that, this is identical conceptually to this in Java, right? And like tables are in relational databases is the equivalent of collections in non-relational databases. All right. Okay. Excellent. Good. Let's continue. What else do we have? Well, in the Java world, we had these DAOs. Right? These DAOs, what were they? What were these DAOs? Well, the DAOs were, let's look at the user DAO. The repositories. So what is the repository? So if you remember, the repository was what? Is just basically some generic mechanism that knows how to talk to a database. It knows how to CRUD, right? So this is a generic CRUD operator that you just need to tell it what it is that you want to CRUD. Like, what is the user? The user is the schema that says what tables is this going to map to. Well, isn't that exactly what we're doing here? Here in the model, remember, what's the model? The model is going to provide me all the CRUD. Here's create of CRUD, create, update, right? You just need to tell me what it is that you want to CRUD, the schema. See that? So this is conceptually the same thing as a repository. Okay, same thing as a repository. Right, so this is the beauty about looking at many different languages, many different infrastructures, many different ways that things are implemented. Once you know, what software engineers, you know, they don't want to you don't want to become expert at one single infrastructure about one single language. You want to be a polyglot. You want to be learning many languages, and once you're exposed to a wide variety of solutions, you start seeing patterns. You start seeing how, you start understanding things much more conceptually, as opposed to being, not seeing the forest because you're so busy looking at one leaf. Okay, you want to be able to step out and says, "Oh, holy cow, everything's the same." Okay, that languages might be different. You might say one thing in Spanish or a different way of saying Italian, in French, and then you realize that, oh, wait a minute, these are all Romance languages. They all come from Latin, right? And there's things that are in common, right? And so you want it to be a super language. You want to be able to grok these languages, right? And maybe even define your own, right? Define your own and says, oh, all these languages are garbage. Let me come up with my own language, which is a superset of all other languages, right? And invent the future, right? Okay, so, but you can only have that knowledge when you're able to step back, right? And see the forest, right? And be able to, look out in the horizon and see what's coming down the line, right? Or even create your own horizon. Okay, so enough philosophical. Okay, so so this is kind of the same thing as the repository. And it's used for what? It's used for implementing the DAO, right? So let's do the same thing here. Let's create a DAO. Let's create a DAO in Mongo. Again, the same kind of architecture for DAOs. So we'll need the user DAO. We'll need the user DAO. So users DAO. Okay, so what does a user DAO have? Well, according to our application here, DAO have things such as, right, being able to create users, be able to find all users, right? Find users by ID, find updating a user, deleting a user. Hey, we just did that, didn't we? Yeah, it's right here, right? All these guys, create user, right? Update user. Those all should live in the DAO. Okay, so let's move them there. Let's grab all this, find all users, right? Find user by ID, find user by object ID, find delete user, update user, create user. I'm just going to copy this whole thing and I'm going to move it over to the DAO. There we go. Okay, so this is starting to look very, very much like the Java equivalent. And if you've implemented this in Python or Perl or PHP or C#, any language whatsoever, architecturally, it would be implemented the same way. Okay, right? Because again, DAO is an idea, it's a concept, is a design pattern. It's how you design things, irrespective of the language, right? It's a concept that is that goes beyond the language, right? And obviously, you would have to stick to the particular syntax and idiosyncrasies of your specific language. But conceptually, you would be implementing the same DAO, a data access object, right? Where the point conceptually is that, you know, we centralize in one single place anything that has to do with interacting with the database. In this case, users. If you want to interact with sections, then there would be a different DAO for sections. If you want to interact with courses, then there would be a separate DAO for courses, and so on. Everybody good? Okay, so let's keep going. Now, notice that our DAO is built on the model, this model here, right? Which we don't have. So let me bring that model in here as well. Here it is. I'll bring it out over here. Okay. Now this this user model needs Mongoose, so we need to require Mongoose. Let's do that. I'm gonna load Mongoose. And it needs, what else does it need? It needs the schema. We need to load that as well, which is declared where? Well, from here, we need to go up one and then down to models, users, user schema. Actually, I'm not going to put it in a separate directory. I'm just going to put it all by itself. I don't really need it in a separate directory. Let's make it easier. Okay, so we're going to load up user schema. Also, we're going to require it. We're going to up one, down to models, down to user schema. There we go. Okay. All right, everybody good? Everybody still with me? All right. So these are just declarations of functions. We declare a whole bunch of functions. We're not calling any functions, just declaring functions. Okay, just declaring functions. All right. What else? Let's see. Something about notice that if somebody wants to use any of this code, all this code is implemented and only is accessible in this file. Right? Somebody outside of this file can't use any of these functions. And the idea is that folks outside of this file should be able to invoke create user and invoke update user and blah blah blah, all those, right? Very much like we did in Java, right? Java, the way we did that in Java is that we declare things as public, right? Public, 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 and we declare the whole class public. Well, here we can do something similar. The way it's done in Node.js is that you export everything that someone else wants to use. And again, you do it module.exports, and you export a whole object that contains all the functions that you want to export. So you have here find user by ID, find user by username, find all users, find user by object ID, create user, update user, and delete user by username. Okay, so anybody who wants to call any of these functions can require this file, and this is what they would get. They would have references to all these functions. Okay. All right, excellent. Let's keep going. I am going to make a small change here. I'm going to instead of, let's see, instead of having this, right now the data that we are creating, we're using it only to display the content to the console, and I guess that's fine. But more interesting would be that somebody could receive this data as opposed to just printing it out to the console, right? So a more interesting implementation would be not to just print it out to the console, but instead, just return whatever that function uses. So somebody can call this function, and then they would get whatever data that comes back, right? So same thing for update. Instead of just spitting it out to the console, we're going to just return. Same thing, this remove. Instead of just spitting out to the console the results of having removed the user, we're going to return whatever that comes back with. Find, same thing. I don't want to just spit it out to the console. We're going to just return whatever the user is. And find, let's see, this one too, right? This find. Here we're just spitting it out to the console. That's not very interesting. So instead, we're going to return that user. And same thing here. I'm just going to return. And this find returns everything. This find all users. And we're going to return. Okay. So a slight modification so that we could use whatever data that comes back with. Everybody okay? All right. All right, excellent. Let's keep going. Now, whoever wants to use this, actually, let's see if we can actually use this. All right, let's use this. So hello.js. Now we can rewrite hello.js as follows. Right? We don't need the models anymore. We don't need any of these functions anymore because they exist in those other files. So we can just blow all this away. We don't need the schema either. Right? That lives in that separate file. So the only thing that we're going to leave here is the actual connection to the database. Right? We connect to the database. We just need that DAO. Right? We just need that DAO here. And the DAO is going to export all these functions, and we should be good to start playing with this. Okay, so let's do that. Let's do that, right? So let's load the user DAO, const user DAO. We're going to require it from the DAOs and then the user DAO. Okay, now we have access to, we can call user DAO dot, look at that, all those functions, see that? Find all users, find all users. So we should be able to just call it from here, find all users. All right. Okay, so let's try it out. Let's see. Now, this find all users, okay, has a funny, you'd think that you could do this, right? Find all users is returning what? Find all users is returning everything that find is returning, right? And what does find return? Well, according to the database, find just returns all the records, right? Well, it turns out that it doesn't come back with all the users, okay? Unfortunately, this doesn't return users. Actually, let's print it out. Let's do console log users. Let's see what that does. So let's run hello. Let's do node hello. Okay, it's not actually what we were expecting. Okay, it's some really big piece of objects here. Okay, it returns a query. It returns a promise, right? And it returns the structure of the data, the database and a whole bunch of stuff. But not the data we want. It even returns the schema of the data. Okay, so it's not quite what we want. So instead it returns as follows. We need to instead it's used as follows. Let me show you. So what this does, it returns a promise. A promise. Okay, and so promises are it's a software engineering mechanism for doing inter-process communication, right? So oftentimes you don't just have your program running, but you have multiple programs that are running simultaneously. In particular, here we have the database Mongo is running in its own thread, and the operating system in the background is running. You can see it running right here, right? This is our database running here in the background, okay, listening for queries. And Node.js is also going to be its own thing running, which we can run it by saying, node hello.js. So these two processes are running, and the way they communicate, usually, through a network, is using what is called asynchronous communication. Asynchronous communication, right? Now, asynchronous communication is we humans actually use asynchronous communication all the time, right? For instance, so there are two types of communication. There's synchronous communication and there's asynchronous communication, right? So synchronous communication is what we're doing here right now, right? I say something, you might say something, right? I might ask something and you might answer, and you're presumably hanging at the edge of your seat at every word that I said, or not. And so you are consuming this content synchronously. If instead you're watching this on YouTube, maybe tomorrow, then you are consuming this content asynchronously. And they're fundamentally different, right? Synchronous communication relies on a conversation that happens at the same time, right? It's what you would do on a phone call, right? I say something and you say something, or in a conversation, right? That's synchronous communication. Asynchronous communication is what you do when you read email. That's asynchronous. Or when you read text, right? Or when you watch this video tomorrow. Okay, that's asynchronous, where we are still collaborating, but we're no longer waiting on each other's acknowledgement, immediate acknowledgement, right? It could happen at a later time. And so asynchronous communication is oftentimes better, depending on what you're doing. It might be better to do it synchronously, or it would be better to do it asynchronously, right? So some processes are better if they're synchronous, and some other processes are better if they're asynchronous, right? So for instance, if I go out and buy and want to buy a donut, a Dunkin' Donut, ideally, the process of me buying a donut is asynchronous from the fact of producing those donuts, right? Imagine that it would be synchronous, right? If it's synchronous, then that would mean that I walk up to the counter and say, I want a chocolate donut. If it's synchronous, right, then that person has to go out in the back, right, make the dough, cook it, come back, 5 minutes later, and they give me the donut. I pay and I leave. So that creates a bottleneck of me having to wait for someone to produce something for me to consume, right? So those processes could be very, very slow, right? And so ideally, instead, we create a buffer. And those buffers is where we can perhaps have some improvement in performance, right? If we can decouple me asking for the donut and someone producing those donuts, and we work at our own pace, we would have a buffer where the donut producer fills up the buffer of donuts so that I can come and consume those donuts, right? And I can say, can I have a donut? And so I take the donut and I can leave, because the buffer, there would be that buffer over the time, right? Grows and shrinks and grows and shrinks. But it gives some time to the producer to see how the consumption is going, right? If the day is slow or fast, right? They can see whether the buffer is full or empty, and they can give themselves some chance of filling it up. Other examples of asynchronous communication is a printer, right? Printers are also asynchronous because there's only one, and there's a queue that gets filled up, and then the printer consumes that queue, right? And then it notifies you when that print is ready. So same thing with databases. Databases, when you have inter-process communication, ideally that communication doesn't happen synchronously, because otherwise you would have one process waiting on the other process to respond. Okay, so oftentimes these processes, we want to decouple them so that we can improve performance, so that if Node.js has to wait for the database to process the response, well, the database could be halfway across the world. It could take half a second, or it could take 10 seconds. I don't know. But ideally, Node.js would not just sit there waiting for the database to come back, right? Ideally, Node.js could say, well, hey, get me the list of all users, and go ahead, you work on that while I go and do something else. Okay, like I send you a text. If I send you a text, I usually don't expect you to answer the text immediately, right? I send you the text, and then I go doing something else. If I really want an answer right away, I would call you on the phone and we talk synchronously. But we can decouple our work by leaving you a voice message, or I send you an email, or I can text you, and you can do that on your own, and then I can go do something else. So similarly here, promises is the mechanism by which we can decouple the database process, right, from the program that is using that database, right? We don't want them coupled and waiting for each other, right? So a promise, like the name suggests, the promise is it's a commitment. It's a future commitment to fulfill something. Okay, so what this find all users sends you back is a promise. Say, hey, I promise that I'm going to work on this. Okay, you go do something else. Meanwhile, I'm going to work on this that you asked for me, and leave me a phone number so that I can let you know. I'll call you back when I'm done. Okay, I'll call you back when I'm done. So leave me a callback. Right. So here we can leave a callback. All right, and that callback is in the form of a function. It's a function. I'm going to call back this function when I'm done. Okay, and the way that I'm going to call you back is I'm going to say promise. Hey, promise. When you're done, when you're ready, then call me back. So promise when you're done, then call me back. Okay, so I'm gonna leave you a phone number for you to call me back, and you're gonna pass me the data there. Once you come back, right, and the database comes back, says, hey, I got the users you wanted. Here they are. What do you want it? All right, I can drop it off where you want it. So here are the users. I'm gonna pass you the users. I'm gonna call that function that you left me. I'm gonna pass you the data, and then you can do whatever you want with it. In our case, I'm just gonna spit it out. Okay, this makes sense? Did I lose anybody? All right, let's try it out. Let's see if this blows up. Okay, let's try it out. So let's do Node.js. There they are. Look at that. These are the users that came back from the database, right? It's right here in this object. If you don't believe me, we can put a breakpoint here. Actually, no. It's coming back here, right? And it's spitting out that content. Before, notice that it just, spitting out some garbage there, right? But now we have the data. Everybody good? Everybody still with me? Did I lose anybody? Okay, promises is I think promises is has a steep learning curve, right? Most people get lost the first time they are introduced to promises and inter-process communication in general, right? And asynchronous communication in general, right, is hard to grasp. The programming model that we were all taught, when we were young, is that we think always of programming from top to bottom, from left to right, right? So that when you make a function call, the way we think about that function call is that, okay, the function is running, and here I'm waiting for that to happen, and I'm not going to continue until that function comes back. But and that's yes, 99% of the time that's true. Most programs are written that way. Okay, where things happen step by step, right? From top to bottom, from left to right. Okay, that's synchronous programming, right? Asynchronous programming is slightly different, right? Asynchronous programming is everything's happening at the same time, and you have messages coming back up and interrupting each other, right? So I'm doing something, right, and I send you a message, and I don't wait for that. I just keep going, and then you call me back saying when you're done, right? And you interrupt me while I was doing something else. So that's a completely different way of thinking about programming, which, when you're talking about databases, or when you're talking about, talking to remote resources, right, it becomes more and more relevant to understand how that works, right? So here's an example. Okay, so this is a little bit too verbose. There's way too many things happening here, right? We can rewrite this. We can rewrite it using the following. Okay, so instead of writing all this, we can rewrite it as follows. So user DAO dot find all users. So find all users is going to return what? The promise. Yes? Well, and that promise has a function .then on it. See that? So promise. So really, actually, instead of rewriting it here, let me copy this, right? Let's rewrite it. But I'm going to leave it. I'm going to leave it here for historical purposes. But we can rewrite this as follows. So this promise is not being used anywhere else but here. So we could just remove it from here. And we can just remove this from here. And basically, this is exactly the same thing. Yes, it's exactly the same thing. And this callback, right, depending on whether we use this ever again, usually these callbacks are only useful here. They're only useful here. They're not useful anywhere else, these functions. So some might say, why even bother declaring a brand new function? You know, why not just move this in here, right, and not declare the function at all? Okay, so this becomes something like that. All right. So if we run this again, you'll notice that it does exactly the same thing. So we run it. Okay. There it is. Notice that it does exactly the same thing. All right. Okay, excellent. So user DAO worked. Perfect. How about let's try another one. Let's use what else do we have in our DAO? We have find all users. How about find user by ID? Okay, so how would we use that? I'm going to comment this out. We'd use it as follows, right? We would say user DAO dot find user by ID. Right, and the ID is, let's see, we have an ID here. Let's return Alice. This one, copy. All right, and this would come back then as the user. And then we print out console log user. All right, let's try it out. Let's run it. And here's Alice. There it is. So yeah, it works. It works perfect. Okay. How about creating a brand new user? Let's use the user DAO create user. Right. Let's create a new user, and this will be first name is Bob, Charlie, Dan. Maybe we can put it like that. Last name, and Daniel Craig. And what's going to come back? The actual user that we just inserted. And we're just going to do console log user. Okay. Let's try it out. Let's run this. And there it is. Daniel Craig, we just inserted it. We can verify that by doing a find all. There's Daniel Craig. We just inserted Daniel Craig. Let's insert a couple more. So Daniel, A, B, C, D, E, Edward, Norton. Let's run that. Let's do a find here in database, and there we have Daniel and Edward. Okay, let's do an update. Let's user DAO dot update user. We need the ID, so let's update. let's update Daniel. So we'll need the ID, and we need the new data. So we'll change. Let's see. I forget how we implement the user ID. Update. Okay, yeah, we can change the first name and the username. Actually, this, right? Notice that we are updating first name, we're updating username. What about last name? Any other field? Any other field? Well, isn't that just the object here that has already a first name, already a username? So we could just say this. Could just say set and then new user data, which has all the fields and the new values, right? So that's much more generic, right? So here we can change Daniel's first name. Instead of Daniel, we'll change it to just Dan. And here we can say then. And remember, what comes back is a status, not the object. So we can do console log status. Okay. And let's try it out. Let's run this. And says, okay, that it was able to change it. Let's see the database. So it used to be Daniel. All right, let's do it pretty. And there it is. See that? We were able to change Daniel's to Dan. And finally, let's do a remove. Let's remove. So this would be user DAO dot delete user by username. Oh, by username. Let's implement delete by ID. How's that? That would be better, right? So we have delete by username. Let's delete by ID. So it's delete user by ID. So you can provide here a user ID. And we're going to remove where the ID is equal to the UID. And we'll export this as well down here. Okay, and let's now we can go back to hello and implement this as delete user by ID. And let's remove, let's see, let's remove Dan. We know his ID. Oops. Use whiteboard, show collections, db.users.find, pretty. Okay, so we're going to remove Dan, copy. Remove, and then this is going to come back with a status, then a status, and we're going to console log the status. Okay. Let's run that. Let's see. Let's run that from the terminal. And there it is. It says that, yes, they were able to delete. So if we go to the database and we do a find again, notice that Daniel is no longer there. All right. Did that make sense? So we just showed you, right, that we were able to restructure our application so that it's more based on an architectural way of how to break up applications, right? We saw that it's actually very similar to what we did in Java. Again, if you were using Python or Perl or any other language, right, you would follow similar architectures that because these are designed patterns, right? Best practices that are applicable throughout the industry, regardless of whatever infrastructure you might be using. Okay. All right. Any questions? All right, that's all I had for you. So please come, Tuesday with questions about the project, things that we might help you with, concerns that we might resolve here in class synchronously, or if you prefer asynchronously, we can certainly obviously answer questions on Piazza. But if you do need conceptual things that we want to cover, please come with those on Tuesday. All right. All right, folks, that's all I have for you. Thank you.
Thank you.
Bye. Thanks.